Good morning, students. I am Dr. Pradeep Johnson, professor in the Department of Mechatronics Engineering. Today, I am going to discuss about the basics of digital image processing. So, as all of you would have heard the term, a picture is worth more than 1,000 words. That saying is nothing but the image gives a much clearer impression of a situation or an object. So that is why image processing plays a very important role. So having an accurate visual perspective of things has a high social, technical and economic value. So mainly the digital image is used for improving pictorial information for human perception, processing of image data for storage, transmission and representation for autonomous machine perception. So coming under the category of image processing, it is used to perform numerical operations on higher dimensional signals such as images and video sequencing. The objective of image processing include improving the appearance of visual data, extracting useful information, representing the image in an alternate and possible more efficient form. So what is digital image processing? So the field of digital image processing refers to processing digital images by means of a digital computer. A digital image composes of finite number of elements which have a particular location and value, and these images or elements are referred to as picture elements, image elements and pixels. So digital image is broadly classified into a two-dimensional array of pixels where the width is classified as n pixels and height is classified into m pixels. Overall, the data file size is mentioned in the notation of n into m into n. So images are referred to more than just the projections that is generated by a visual band of electromagnetic waves which is apparent to humans. And some of these images include ultrasound, electron microscope generated and computer generated images. So you can see a sample images of size 2048 by 2560. This is sample image, and this is again an example of a graphic image, and the third one is an example of a video, and this one is an example of an animation. So there are three computerized processing levels. One is known as a low level process, which is characterized by the fact that both the input and output are images. And the next one is a mid-level process, which is characterized by the fact that its inputs are generally images, but its outputs are attributed extracted from those images such as edges, contours, and the identity of individual objects. And the next one involves high-level process that involves trying to deduce and recognize the objects, and from the image analysis it is classified into different individual objects. So what are the origins of digital image processing? So it was in the early 1920s, the Bartlein cable picture transmission system was introduced, thereby reducing the transportation time from picture from New York to England. There were different phases in this technology improvement. In 1921, the method used for receiving images through a coded tape by a telegraph printer, and this was abandoned later in favor of a technique based on a photographic reproduction made from tapes perforated at the telegraph receiving terminal. So this enhanced the quality and resolution. So some of the fields that use digital image processing are medical imaging, earth resources observation and astronomy. And the main application nowadays we know is used in medical imaging, where it is used in multidisciplinary nature like quantum mechanics, fluid dynamics, and biology, chemistry. and it has become a primary component of modern medicine. The invention in the early 1970s of computerized axial tomography, or otherwise known as CAT, is one of the most important events in the application of image processing in medical diagnosis. Today, this CAT plays a very important role in the medical field. So again, this is an example of CAT, where you can see an X-ray CT. Moving on to the next category of computer tomography. Besides the natural images acquired from conventional optical cameras, computer synthesized images become more and more important in many application fields. It helps in the non-invasive imaging modalities which allow people to view objects that cannot be seen by human eye or camera. For example, internal organ of human body, damaged part of an airplane wing, dark night battlefield, etc. So how do you do the image enhancement? So this is an example of an original image where you can see right side the histogram, and this is a histogram which shows the poor contrast. Again, example of an image which shows poor contrast, and here we can see an enhanced contrast of the same image, and also smoothing and sharpening examples of the same image that helps to enhance the image quality, and these factors contribute to the increased image clarity. So moving on to the next category of image analysis, this is used to identify and extract useful information from an image or a video scene. For example, image processing generally involves pre-processing, object representation, feature detection, classification, and interpretation. So moving on to the next category of image segmentation. It is an important pre-processing tool. It produces a binary representation of the object with features of interest such as shapes and edges. So common operations that we perform here is thresholding. It is nothing but to segment an object from its background through a simple pixel amplitude based decision, and the other one is an edge detection. It is used to identify edges of an object through a set of high pass filtering. And this is an example of a segmentation example. The first one is thresholding and the second one is an edge detection. And moving on to the feature extraction. So this is an area of image processing that uses algorithms to detect and isolate various desired portion of a digitized image. So what is a feature? A feature is nothing but a significant piece of information that is extracted from an image which provides more detailed understanding of the image. So some of the examples of feature detection are detecting of faces in an image filled with people and other objects, detecting of facial features such as eyes, nose, mouth, detecting of edges so that a feature can be extracted and compared with another image. Thank you.